Hi guys, this is my second video on circuits and voltages and currents and resistance. In the first video, I'm not sure, I wasn't very clear about the current thing, so here it is again. So here's our voltage source, and this is our circuit. It's badly drawn again, so I'm sorry about that. Well, the electrons or the charges actually move this way, from the negative to the positive terminal. But the current itself moves from the positive to the negative terminal. And standardly, we use this direction as the convention current, from positive to negative. So that's just a quick point about that. And next thing we're going to talk about is resistance. So resistance is just a way of saying how a material can conduct current. And it's the equation for resistance is R equals V over I. So it's like how much this material is opposed to the current moving through. What's the units? Well, if we find the units here, that's volts over amps. Well, in physics, we give a special unit to this name. It's called ohms. Symbol is like that. It's kind of weird looking, and this leads up to Ohm's law. Let me erase all this. What does Ohm's law do? Well, Ohm's law relates all these three examples of current, voltage, and resistance, and you saw it in the last equation already. So this is the most fundamental equation. So it's V equals IR. V is the potential difference of the voltage, and I is the current, and R is resistance. So here's a practice problem. Let's say that I is doubled, and then oh wait, no, that's a bad example. So let's say that V equals that the circuit has, across this one resistor, this resistor has a resistance of 2 ohms, and its voltage is, let's say, 3 volts. What would be the current traveling through? Well, we would just solve for I in this instance equals V over R, which would equal her, so here V equals 3 and R equals 2. Just equals 3 over 2 amps, of course. Sorry, that was really badly drawn. I need more practice with this. By the way, so a good movie that you guys should watch is Horrible Bosses. It was really funny. Alright, sorry, that was off task. Okay, so we're going to talk about this term called resistivity. So it's called resistivity. I'm not going to even write that down. The symbol for it is rho, and rho also means density, but in this case it's the property of a material that affects its resistance. And basically this is proportional to R, so the higher this is, the higher R will be. So another equation for resistance, so right here in a second, is R equals rho L over A. So what are all these variables? Well, L is the length of the material, A is the cross-section area of a material, and then rho is the resistivity. What is the units of this resistivity? Well, the unit is ohms times meters. And if you want to know why that's the case, let's say, so we're going to do our little unit dimension sys, something like that. So this would be unit times meters. What would L be? L would also be meters. And what would A be? Over meters squared. And we see in here that this cancels out with this, so it has to be meters. I mean, rho times meters. What does this equation tell us? This equation just pretty much tells us that the larger the area, the smaller the resistance, and larger the length, the larger the resistance. So let's say that we had a wire that had a resistivity. Hold on, let me write this down. Let's say the wire has a resistivity of, let's say, here I'll come up with the value 10 to the negative 8 ohms times meters. That's A right there. And then let's say it had an area of let's say 4 meters squared, and it had a length of 6 meters. No, wait. Let's say it had a resistance of 4 ohms. I mean 6 ohms. 6. And this is an 8 right here. What would its length be? So I'll give you some time to solve this. Alright, so here's how you would approach this. So here's a 6 right here, this is a 4, this is a negative 8. So let's erase all this. I'm gonna use red this time. It would be L equals R over rho A, and you just plug in the values. That's it. This is a rho, right? This is an R right here. So that's pretty much all there is to it, I guess. I think that's gonna be all for today. And so in this video, we learned about resistance mostly. And we learned that resistance is a measure of how much a material opposes a current. And we also learned there are 2 equations for resistance. Ohm's law, which is V equals IR, and the other equation, which can be used if you know the length, the area, and the resistivity of a material, which is R equals rho L over A. So thank you guys for watching, and please come back for the next video. Thank you.